So here's a quick little how-to on question number 2, the addition sine squares one. So the first thing it asks us is to draw the next two diagrams. Before we can draw the next two diagrams, we need to know what the pattern is. So if we look at the pattern above, in figure 1, we have 5 squares. In figure 2, we have 9 squares. And in figure 3, we have 13 squares. By looking at those three numbers, we can tell that the difference between each of them is 4. So every time you are adding 4. 5 plus 4 is 9. 9 plus 4 is 13. So if we take 13 and we add 4, we know that there will be 17 squares in figure 4. And again, if we add 4, we know that there will be 21 squares in figure 5. So now we know how many we should have to draw it. If we just take this one here, and we'll take figure 3 and add it there, and we'll add another figure 3 to figure 5, and our drawing for figure 4, the pattern was we're adding 4, or essentially we're adding 1 square to each arm for a total of 4 new squares. And this is figure 5, so we're going to have to add 2 squares because we just used figure 3, and that will give us a total of 21 squares. Once we've completed the drawings, we have them in. The next thing says we need to construct a table of values. We're going to use the table of values and the diagrams we drew to fill this out. So if we look at diagram 1 had 5 squares. Diagram 2 had 9 squares. Diagram 3, or figure 3, had 13 squares. Diagram 4, or figure 4, had 17. And number 5 had 21. So if we make that a little bigger, there we go. So now we've completed our table value. We have our x, we have our y, we have the diagram, and we have how many squares will be in that diagram. Question 3 says, describe the pattern, the vertical or the y numbers only. So the only thing we are going to be looking at is we're going to be looking at these y numbers here. What's the pattern? Well, we know from up here the pattern was you're always adding 4. So describing that pattern, we will say the pattern is to add 4 squares to each new diagram. The next question, describe in words the relation between the diagram x and the number of squares y. And that's horizontal, so we're looking for the relationship this way. We're looking at what is the relationship between 1 and 5, 2 and 9, 3 and 13, 4 and 17, 5 and 21. So we need to come up with a relationship that they all share. So this is where it can get fairly difficult. We need to figure out how to go from 1 to 5, 2 to 9. One thing that we know is you're always adding 4. Adding 4. Adding 4. So that's going to give us 4x. So to get the x, to find the y, we have to times x by 4. So if we go 4 times 1, that only gives us 4. 2, if we go 4 times 2, that only gives us 8. If we keep going down, the problem, we're always 1 off. So for this pattern to work, we need to go times 4, add 1. So if we go 2 times 4 is 8, add 1, we will get 9. If we go 3 times 4, add 1, we will get 13. So to describe this in words, we want to say y is always 4 times plus 1 higher than x. And the final step we need to do is create an algebraic formula for this relation. And that formula will be, we're going to have y. Y is always our output, so our answer. Y equals four times x plus 1. So if we were to punch any of the x's in for x, let's say, erase this. If we were to punch any of these x numbers into here for x, the y would be equal to the stated y on this side. So for example, if we put 1 in for x, we have 4 times 1 plus 1 will give us 5. So our y is equal to 5, our x was 1, and it matches our input-output chart. So we have the correct formula. So moving on to the backside, we have question 5, graph the relation and label the graph including the x and y axis. Give the graph a title. To be able to do this graph, we're going to need to use the x and y chart from the previous page. So where we drew our addition signs and then we filled in the diagram and the number of squares, we're going to need that. So using that information, using this information here, we're going to graph this by plotting the coordinates. So when we have a graph, the vertical side will always be our y-axis, the horizontal side will always be our x-axis. We're always going to start with a 0, 0 right in the corner, so zeros and zeros will be right on the lines. And then each line is going to go up by the same amount of increments. So if we look at our y side here, the highest number we need to get to is 21. We do not have 21 lines, so we're going to need to go up by 2s. So each one of these lines will be 2, 4, 6, 8, 10, 12, 14, 16, 18. And if you're putting them in, you should be able to have enough to get up to, I believe, 24. It'll look a lot nicer than mine. And going on the x-axis, we need to go from 1 to 5. So we can easily fit 1 through 5 on there easily. And we want to make sure that each one is on each line. So we have 5 lines and we have 5 numbers. Once we have this and we have this, then it just comes down to plotting. So we're always going to just erase these lines. And let's change our color. we're always going to go from x first. So x is 1, y is 5, so we're going to start on the x at 1, and we're going to go up to 5, right about there, and whoops, put our dot. Second point is 2 and 9, again, x2, so we're going to start at 2 first and go up to 9, so on the 2 line, put a dot at 9. Next one says 3 and 13, so again, start on the 3, and we're going to go up to 13, just drawing a line so you can see, and put our dot. And continue on with 4 and 17, so 4 and 17, and then again at 5 and 21, which I'm sure yours will fit a lot nicer on the graph. The key to know if you've done this right is all of these little dots and all these points should fit on a straight line. So they're all linear equations. So it all should fit on one straight line. If for some reason you had a dot out here or a dot there, then you know that you have done it wrong and you don't have the right numbers. So everything should fit on a nice straight line if you're punching in the correct points. If you do mess up and put x over here and y over here, then you'll have they'll all be in the same line, but they'll be going in a different direction than this one. So we have the graph is done, we've got it labeled, now we can move on to question 6. Question 6 says, how many squares will there be in the 54th term? So in the 54th term, so that means diagram 54. So you have diagram, and you're wondering how many squares. So you have the x, you're wondering what the y will be. So if we were to punch this in, so again, I forgot to mention, you're going to use your same formula. So y equals 4x plus 1. The same formula we created on the last page, you're going to use now. So you put y equals 4x plus 1 in, and then you need to take 54 and put 54 in for the x. So we've placed 54 in for x, so now the new formula is y equals 4 times 54 plus 1. Again, we're trying to figure out what y is, so all we need to do is just do exactly what we see here in order of operations. Go 4 times 54, and when we do that, we're going to get y equals 217. So that's all we need to do for that one. A is solved, so in the 54th term, or the 54th diagram, there will be 217 squares. So you'll do the same for the 37th one. You'll go y equals 4x plus 1, and then you will put 37 in for the x, and then just simply 4 times 37 plus 1, solve, and you'll get your y equals. For question 7, it says, in what term will there be 81 squares? So now you're working backwards. It's telling you the term, but it's asking you how many squares. So that means work backwards means that you know what the y is. So for y, we can punch in 81. So you'll take this 81 and we'll put it in for the y. So now we'll rewrite it, and we'll rewrite it as 81 equals 4x plus 1. So now we need to figure out what x is. We can just simply guess and check. So we could go 4 times, let's say, 10. 4 times 10 is 40 plus 1 does not equal 81. So it cannot be 10. So we could try again and go another guess and say, what about 4 times 20? 4 times 20 is 80, plus 1 is 81. So therefore, we know that it should be 20. So when you're recording your answer, you just need to make sure you record it as x equals 20. And then that way, we know that x is 20. So if we would put 20 back in for x, 4 times 20 plus 1 equals 81. Another way to answer this question, if you don't want to just guess and check and put numbers in for x, is to just kind of go through it solving. So the first thing we want to do is we want to get x and the 4 by themselves on one side. So to get rid of this little 1 over here, we need to do the opposite of plus 1. The opposite of plus 1 is minus 1. If we minus 1 from this side, we have to do the same thing to the other side of the equal sign. So we need to minus 1 over here. So by minusing them, it cancels out this, so that is gone, and this becomes 80. So we now have 80 equals 4x. And now, to get x alone, we simply, this is 4 times, so the opposite of timesing is dividing. We will divide by 4, and 80 divided by 4 is 20, so that we would get x equals 20. Or just reverse it, x equals 20.